Do you ever find yourself staying awake all night and losing a lot of sleep?
As a result, you may find yourself drinking caffeinated beverages to wake yourself up.
But how does this work?
Caffeine has a formula of C8H10N4O2.
Here is the chemistry name of caffeine.
Pure caffeine is a white, bitter solid. It is an organic compound of the alkaloid group. Caffeine has similar structure to cyclic adenosine monophosphate, or CAMP.
Because of the similar structure, caffeine bonds to the adenosine receptors in the brain, where CAMP does.
When CAMP bonds to the receptors, the brain receives signals leading to fatigue, but when caffeine bonds to the receptors, it blocks off the CAMP, making the body more energetic.
Here's an example of what happens in your brain when you intake caffeine.
Starring the drowsy CAMP and the energetic caffeine at the adenosine receptor. Now that caffeine is in the receptor, feelings of drowsiness and fatigue from the CAMP are blocked off.
But the brain-stimulating neurotransmitters dopamine and glutamate are not blocked off and continue to flow into the brain.
You get a mild jolt of energy as your dopamine levels are increased.
Basically, dopamine keeps coming in, making you more excited and energized. Caffeine blocks off the sleepiness, which then helps natural stimulators with energy such as dopamine or glutamate to keep coming in. Here's the summary of what we mean. As you can see, caffeine does not allow CAMP to go in, but it allows dopamine and glutamate to go in, giving you more energy.
The sympathetic nervous system is involved in the fight or flight response. When CAMP is blocked, the transmission strength of neural signals in the system increases.
Caffeine's effects on the brain increases neuron firing. The pituitary gland senses the actions and sends hormones to your adrenal gland.
The adrenal glands then will prepare to produce adrenaline. Adrenaline will increase your heartbeat and your blood pressure will rise. Your muscles will tighten and will be ready for action.
After consuming a caffeine, your concentration of serotonin increases around the brainstem, which increase your spinal motor neurons, leading into the firing of skeletal muscle motor units, giving you better utilization and lower exertion. Do you ever wonder how long caffeine stays in your body? Studies have shown that the half-life of caffeine in a healthy adult is 5.7 hours. Of course, that's not all, because people's body are different, but basically a half-life should be around 6 hours for caffeine. To make sure there are no overdose of caffeine, experts have said that you shouldn't have over 600 milligrams of caffeine a day. Coffee is not the only beverage with caffeine in it. Here are a list of things with caffeine. We hope this was helpful and will come into your mind when you drink your next cup of coffee. Thanks for watching!